And we're live. Welcome back. It looked like we had some issues with YouTube. So this is take 2 for the virtual IoT meetup about NGINX and MQTT. So we're very happy to welcome all the new participants. And I can actually confirm that we are indeed live. So that's great. So we'll probably need a few minutes for people to collect. So I might as well use that for doing maybe a slightly longer introduction than usual. Yeah, a couple announcements. There's a few meetups scheduled for next month that you may want to already check out. I think we're going to talk about among other things about Eclipse Ditto, which is a very nice open source project for doing digital twin. So you probably want to check that out. And another great thing is a new thing is the IoT developer survey. So you might remember that from previous years. This is the fourth time we're doing the IoT developer survey. So I will be posting a link in the YouTube chat, and then we can certainly talk more about that at the very end. I don't want to wait any longer now that we're live, and at least half of the participants are back. Thanks for your patience, everyone. It looks like we need a replacement to YouTube and to Google Hangouts at some point. So welcome back, and welcome back, Liam. Really happy to welcome you to our meetup. Sorry for the technical issues. Why don't you tell us all about NGINX and MQTT, and maybe go over the few slides that unfortunately we couldn't see just minutes ago.
Okay, thank you, Benjamin. And yeah, I don't think I want to make everyone see the same slides again. We didn't get very far.
They didn't see them though.
And yeah, but this time we can see them, and at least we didn't miss any of the demo part. So then I'll just bring us back here, as I was just recapping on the story of NGINX and how it was created by Igor, and how we got from there to today, where we have extremely popular open source project. It's running pretty much almost exactly 400 million websites across the internet, according to Netcraft figures. And we estimate that at least half of all of the internet traffic, at some point is going through NGINX software, either at the front end or close to the back end. And of course, NGINX is a big part of what makes the Netflix network work, serving video traffic, and so that counts for a huge amount of data. So beyond that, we're a global company. Headquarters are in San Francisco. I'm speaking to you today from Cambridge in the UK. We also have a EMEA headquarters in Cork in Ireland. Much of the engineering for the core NGINX product still happens from Moscow, and we have a new office just recently opened in Singapore. So you have this. I'm now one of over 200 people that look after the open source project and that run up the commercial operations as well. And so I was talking about adoption of our open source reverse proxy web server. There are many use cases, and I think that the most interesting statistic about that is that NGINX is number one for the busiest sites on the internet. Now, of course, most people, if they haven't heard of NGINX, when I speak to them, I ask them if they've heard of Apache, and that every single person has heard of Apache. So, but when we look at the busiest sites on the internet, say that the top million busiest sites, NGINX is most commonly used. So number one, and it has 44% of those sites. But as we look at even busier sites than that, the top 100,000, 55% use NGINX, and the top 10,000 sites, 63% use NGINX. It's fair to say the busier the site on the internet, the more likely it is to be running NGINX as part of that platform. And this data, I pulled it just yesterday. So another reason that NGINX is popular is because of its low memory footprint, low resource utilization, very efficient use of memory, especially as it scales. And that's a reason why NGINX has become extremely popular. In fact, the most popular image on Docker Hub. It's very well suited to constrained environments. And of course, that's my segue into the suitability for NGINX for running inside an IoT platform as well. And just to mention that As well as NGINX, the open source project, we have NGINX Plus, which is our enterprise grade offering, targeted mostly at replacing old-fashioned hardware load balancers. You'll find NGINX Plus on the Gartner Magic Quadrant for such technologies, and it adds on top of the open source project additional capabilities for caching, load balancing. Web application firewall is available for those websites, and also additional monitoring and management tools such as a web-based dashboard, which I'll use in one of the demos coming up. But I know you're thinking, Liam, stop talking about HTTP. This is supposed to be about IoT, so I will do that. That's the end of my talk about NGINX and our traditional use cases in the web world. Let's focus on MQTT instead. So we run a survey every year, and we ask our NGINX commercial customers and our open source users how you're using NGINX. And of course, as you'd expect, along the left-hand side here, we see the most common web-based use cases that I'm not going to speak anymore about. But you'll notice that many users, and in fact, more than half of our commercial customers use NGINX for load balancing TCP and UDP applications. And this was a new that 10% of our existing customers are using NGINX for those type of solutions as well. So this is something that we genuinely see an increase in, and more of the conversations that I have with our customers are about IoT projects. But you know as well as I do that we're not the only company that runs a survey. And of course, the Eclipse Foundation runs the IoT Developer Survey every year, and it's something that I always look out for very, very keenly. And of course, I'd encourage you to contribute to that again this year. And we'll see over the last couple of years, the question that interests me the most is about messaging protocols. And of course, we see, there's no surprise maybe, that HTTP is up at the top. So no more about that. We're all good for these kind of use cases. But it's also clear to see that MQTT is a very strong second place. Certainly has been the most popular messaging protocol that I've seen in our customers. But it's also worth noting that CoAP has increased in popularity by 5 percentage points, from 16 to 17. And if the conversations that I have with customers are anything to go by, I expect that to jump up a lot more when we see how people are using messaging protocols in 2018. But it's as simple as this to get started with NGINX. If it's a text-based configuration, and this is really all you need to get started to load balance either MQTT or CoAP traffic through an NGINX node. We use the stream block here to denote that we are dealing with layer 4 as opposed to the default HTTP block. In our upstream group, we define the backend servers, the cluster or the servers that will be handling the traffic, the backend. And the server block defines the virtual server that NGINX will listen on, so that it will present itself as the MQTT broker or as a CoAP server. And we listen on in this case, on the default port for each of those protocols. Notice that for CoAP, we additionally specify the UDP parameter because TCP is the default, if not specified. And then the proxy pass directive simply says that any traffic that arrives on this port will be sent and proxied to the cluster, and it will load balance. Default would be round-robin fashion to each of the backend servers that we define. But we're going to focus on MQTT for the rest of this session. And as you may know, MQTT is a pub/sub, publish-subscribe messaging protocol, and it has a broker, which is a middleware component that acts as a routing agent between clients. So clients themselves publish messages, and they can subscribe to messages, and these messages are on a particular topic, so that they can filter or they can subscribe to only the topics that are of interest for each client. And in order to see this in action with NGINX, I'm going to use this kind of MQTT environment, quite simple environment to show all the moving parts and how NGINX can fit and provide value. On the left-hand side, we have the device network. So here we have our, we can imagine our small constrained MQTT devices. There's a router component that sits between them and the primary network. NGINX is in the middle, of course. And on the right-hand side, we have an MQTT broker cluster. So we'll have 3 separate MQTT brokers. And the configuration needs to adapt to problems with the health of the system. If we have a broker become unavailable, it goes down, we take that for maintenance deliberately, or if it's an elastic cluster, we're adding and removing broker servers in response to traffic load, then we want to make sure that the NGINX component in the middle is only going to send connections to a good, healthy broker. And so the first thing we'll see is how we do that with NGINX. And I'll point out at this stage, just this example here is using a feature that's available only in NGINX Plus. You won't find it in open source. After this, everything else is open source only. So this configuration for MQTT is very much like the simple example that I showed a few slides ago. We have a cluster defined, and we also define with a match block how we're going to test that an MQTT broker is healthy. And the way that we're going to do that is to send an MQTT connect packet and expects to get a connection acknowledgement or connect packet back from that broker. And if we do, then we know it's healthy and we can send new connections to it. So the server block listens as before on the default port, 1883. We'll send all the traffic to the cluster, but in addition, we have a health check directive which requires that we must match the MQTT connect block in order to determine a healthy system. And you see in the match block, the send and expect strings are hexadecimal. MQTT is a binary protocol, after all. So in order to construct the send string, we use Wireshark or TCP dump just to capture a particular MQTT request so that we can replay it. A connect packet. The expect packet, though, is very simple. You see here it's just 4 bytes, and it's fairly simple to construct this just by reading the MQTT specification. Here is the spec for MQTT, and in particular, the CONAC message. And you can see the fixed header has 2 bytes. The first byte sets 1 at bit 5, so that's hexadecimal 20. Byte 2 is the remaining length, and there's always 4 bytes here, so that is hexadecimal 02. And then in the variable header, the first byte here is the session present flag. And we want to make sure that every time we do a health check, we're testing that the broker is able to accept a fresh connection rather than an existing one. So we make sure that's 0. And that leaves us with just the final byte. And this is the connect return code. And of course, we want to make sure that we only test that the broker is healthy when we see the 0 code for connection accepted. And this is the reason why this kind of health check is superior to just testing that port 1883 is up and accepting TCP connections. Because, of course, it's possible that the connect return code might be value 3, which would indicate that although the server is up, the MQTT service is unavailable, maybe it's too busy, or for some reason it's not able to accept new connections. And we absolutely don't want to be sending clients to such a broker. So let's see this in action, and we'll switch to the first demo. I will point out at this stage that the demo system is a little bit flaky. I wrote some code, so that's the reason it's a little bit flaky. I might have to restart it once or twice to get through, but it'll keep things interesting. So just a bit more color around the demo environment. For the MQTT broker, I'm using VernMQ, simply for the reason that I tried a few, and I wanted something that would run nicely in a Docker container on a VM on my laptop, so everything is nicely self-contained, and it was super, super easy to set up a fully meshed cluster with containers. So that's what I'm using there. On the MQTT side, for the devices themselves, I'm using Contiki. It's a real-time operating system. The great thing about it is you can write little simulated devices that you can push code onto real hardware, or just use the Kuja network simulator to watch, have a number of devices up and running at the same time. So we'll use that for the device side. The devices themselves, I'll come to. The environment, just to make it a little bit clearer, I had 2 virtual machines on my laptop. So Oregon on the left-hand side in green, this is where I run the device network. So the MQTT devices run here. There's an edge router connecting a device network to the local network on the VM, and that's where we have NGINX running. So it's acting here as an IoT gateway. And we have another VM called Portland, and this is simply running 3 Docker containers for our MQTT cluster with the VernMQ containers. And this is just one model with NGINX acting as an IoT gateway. It could equally be deployed this way around, so it's balanced onto the cluster. So it really depends on the network environment. It depends on what you need, but we have it this way around for the demo. Okay, so let's before we jump to the demo, just a note about the MQTT device itself. So it's running inside Contiki. It runs on the Z1 moat hardware. It has a light sensor, a temperature sensor, and a network. And it's programmed to connect to the IP address of NGINX as the MQTT broker. So it's aware of just a single IP address, and NGINX, of course, then will connect to the real backends on the VernMQ. So it publishes messages about its sensor values, and it will subscribe to messages as well. So let's now get things up and running. First, we jump to a terminal window, and on Portland, we need to make sure that we actually have a cluster. So let me start 2 nodes in the VernMQ cluster and make sure that they are up and running and joined to the cluster. Let's see. Oh, no, only 1 node in the cluster. Now we have 2 nodes. Okay. And with that in place, let's jump to the Oregon virtual machine, and this is the Contiki simulator. So I have a simulation we can load. Yep. Okay, and here are the different devices we're going to see inside the simulation. Firstly, number 1 is the edge router. So that is our gateway between the sensor network and the virtual machine network. We have a sensor with the same light and temperature values, but this one has an HTTP interface, so we can just check that that's working. And then we'll add some additional sensors with the same functionality, but this time with the MQTT interface. So let's get rid of that, and we'll just start up this network to make sure that it's healthy, just with number 1, the router, and 2, the HTTP interface. So they're up, and they'll get an IPv6 address on the network. And if I point a web browser, where's it gone? At the IP address of the router, we can just check that it's working. It knows it has a neighbor. The IP address ends 202. We'll just make sure that 202 is up and healthy. Go to that address, and we should use the web interface to see what the values are of our device. So that's all great. Let's add some additional sensors, this time of the MQTT variety. We'll put 4 in, and it scatters them at random. So I'll just try and, I've learned after doing this demo a few times, it is least reliable when the devices are far away because it's a lossy network. So there we are. Let's start it again. And so these purple color MQTT devices will come on the network, get an IPv6 address, talk to the router, and then try and connect to the MQTT broker, which we know is going to be NGINX. And if I go back to the web interface for the router, we should see that it now has some additional neighbors and some additional routes. So that's great. Let's get rid of that. Now I'm going to use the Mosquito client, which is a command line MQTT client sitting here on my laptop. And let's make that bigger. Hopefully we should start to see these MQTT devices come online. And we're subscribing to this topic called sensor data. And good news, we have sensor 3 has published, sensor 4 has published, sensor 6 has published, the first in its sequence. And we can see that what they publish is simply a JSON object with a count, a sequence number, an uptime of how long the clock has been running, and the temperature and the light sensor values. So we have still waiting for sensor 5 to come along. Maybe it's broken. Sometimes they don't all work. But whilst we're waiting for that, I wanted to show you the dashboard for NGINX Plus, and in particular TCP monitoring the MQTT brokers. And we can see that we have 2 healthy brokers are up, and they're running on port 18831, 18832. Third, it has failed. We don't have any connections to that yet. So what I'm going to do is go back to Portland and extend the cluster. So I'm going to have 3, and that should show up. Eventually, we should see a health check should be passed, and we should also see connections then being made to that broker. So yes, 18833 is now online, and already it has an active connection. So that's we'll call that success, although it seems that sensor 5 here is flashing its LED. It's not very happy, but all the others are okay. So let me stop that before it breaks, and switch back to the slides. So that's great. We have MQTT devices. They come up, they get an IP address, and they talk to the broker, and they stay connected. But of course, real life is not always straightforward, as my constrained demo environment. In the real world, devices sometimes move around. And so especially if you're using GSM or an LTE network, you might find that you get an IP address, and as you move around the network between cell towers, for example, that you lose connectivity or you reconnect and given a different IP address. And the problem that this can present itself is that you can end up being sent to a different MQTT broker as part of that cluster. And in so doing, there's a cluster resynchronization event needs to happen, an existing session where the session present flag is set to 1, needs to move between one broker and another in order to be fully aware of the state and to minimize the load that's put on the cluster when it has to resynchronize for these events. So what we want to happen is for a client that moves around, let's say our car in this case, it connects initially on the blue line with the IP address 172.345.678 with its client ID. And then as it moves around, it gets a new IP address, the orange line in this case, with a different IP address, but of course, with the same client ID. And what we want to happen is for NGINX to make a smart decision about this and to send the same client to the same cluster broker, the broker server it was connected to the first time. And the great thing is that we can do that with NGINX by using NGINX in conjunction with NGINScript. Now, NGINScript is a unique server-side implementation of a JavaScript engine specifically designed for NGINX and for server-side use cases. So it's not like the client-side libraries that you find in your browser. It's been implemented from scratch and to take care of server use cases instead of client use cases. So the nice thing is it has access to all of the connection information, and you can use a convenient and well understood programming language to make some extensions to the processing behavior of NGINX. And that's exactly what we're going to show next. So this is our modified configuration. And in particular, at the top, we have a JS include directive, which says that we're going to pull in some JavaScript code from this file, mqtt.js. And then we use the JS set directive to create a new variable. And we're going to call it MQTT client ID. And that is set by calling the JavaScript function set client ID. Later on in this configuration, with the hash directive, we then use this variable in order to hash the client ID to one of the set of servers available in the upstream group. And this means that for a given client ID, we'll always choose the same server. So let's have a look at the code, although we won't look too closely. It's about 25 lines of JavaScript, and most of what's happening here is that we start with a client ID string set to essentially an empty value. And if we are receiving the first client message, we know that we have a connect packet, in which case we skip past the fixed header, and then we know that the client ID, how long it is, and pull it into this variable here. So client ID str now contains the value of the client ID, which means that we can use it in our configuration. And notice on the left-hand side, the JS pre-read directive means that we are telling NGINX to call this function before we make any proxying decision. So it happens very early in processing stage. We can use it for authentication purposes, or we can use it in this case so that we can set some information that allows us to make a good load balancing decision. And finally, the set client ID function simply returns that value. Okay. Before we do this, let's go back to the demo, and I'll show you this in action now. Let me jump to my terminal. The first thing I'm going to do is edit the NGINX configuration just to make sure that it closes idle connections very quickly, because I'm going to show you this in a log file, and NGINX writes the logs when the connection is closed. So that's done, and we're still not listening here. Let's go to Oregon, and we're going to just reload this configuration, and at the same time, we will watch the access logs. So reload and start her up. So again, the first device is power on. They talk to the router, they get their IP address, and once they've established the network connectivity, we get a stack trace. So let's go again. This is what I thought might happen. So we'll just reload it, this time with a new random seed. That seems to be a good way of improving our chances. Okay, pairing on, getting an IP. And now they'll try and connect to the MQTT broker. Now remember that these devices, one more time, the devices themselves are configured with the NGINX IPv6 address as the address of the MQTT broker. So they are aware of only a single address, and then the broker itself, or NGINX, I mean, is then able to make the connections out to the appropriate broker at the back end. So that looks a little bit better. Oh, okay, we have some connections already. I should stop my subscription from my my laptop. Okay, here we go. So here's a line. We've got a connection from sensor 6. So the nice thing about pulling the client ID out into a variable means that we can add that variable to our log format, which means that we get the benefit of seeing log activity sensor by sensor. So here we have a connection from client ID with sensor 6, and it likes to connect to the broker with the port number 18833. Sensor 5 also likes to connect to that same port number. That's just the way that hashing works. You need a large distribution of clients in order to get an even distribution of backends. But regardless, we can see that sensor 6 always connects and reconnects to the port 18833. And now sensors 3 and 4 have come online, and they happen to prefer 18832. And so we'll see as each of these sensors reconnects, because I'm telling NGINX to close the connection quite quickly, that it will come back and it will always connect to the same backend broker. Let's see if we can get one more. But regardless, yeah, so sensor 6 again, and so for the 4th time, it's connected to 18833. So we have session persistence working. Again, I'll pause that, and now we'll switch to TLS. So TLS and adding security to IoT environments is a well understood problem, and it's something that I'm sure that is on your agenda. But you might think that, okay, we can add TLS to MQTT. Lots of the brokers that I've come across, they support TLS. Why should we use NGINX for that? So it's true, and I'm not picking on VernMQ here, but if you add TLS support or TLS decoding termination to the broker, it's going to put a huge crypto workload on that broker. And for the same reason that pretty much all web servers support HTTPS or SSL or TLS, it's very common and often best practice to have a front-end load balancer or reverse proxy, such as NGINX, handle the TLS decrypt workload, terminate it early, and then send the decrypted traffic into the private network that handles the application. And the same is true here. We have, my advice would be to scale the message broker, the broker cluster for message throughput, and to scale the load balancer, to scale NGINX for crypto workloads. They're very different workloads. They require very different resource specifications. And for that reason, it's a nice architecture then to separate the two. So we'll see that in action now for the final demo. But it's also worth pointing out that it's not always just as easy as adding TLS, especially when we're talking about constrained devices. And in fact, in my environment, I wasn't able to put TLS processing onto the small virtual MQTT devices that I have in my Contiki environment. But what I can do is apply selective TLS so that the device network with the MQTT devices continues to run in plain text using port 1883. But on my internal network, for my client applications that run inside the platform, I'm going to require that they connect not only with TLS on the secure port 8883, but also that they provide a client certificate, an X509 client certificate, so we have mutual TLS authentication. So if the client's able to handle TLS, we can support that. If it's not, we can support that too. And so what we're going to do to this environment is have selective TLS, so one half is plain text and the other is TLS enabled. So we're going to see what that looks like. The configuration is pretty straightforward. All we're going to do is we're going to split our server block up into two. We're going to listen explicitly on the device network on our IPv6 address on port 883, and on the internal network where the brokers are and where the internal applications live, we're going to listen on the IPv4 address on the secure port 8883. And there are some additional SSL directives that we'll use to configure that. If you're interested, the full list that exists on my test environment looks like this. So we've got cipher levels, TLS protocol is explicitly set, the key pair is there. We've even got a session cache for more efficient handling of TLS sessions if they happen to be arrive on different worker processes inside NGINX. And we require client authentication. So we specify here that we do, and what the public key of the CA that has signed our client certificates. But other than that, the configuration is as before. And so for the final demo, we're going to see if we can get some lights blinking on our MQTT clients. So let's switch back here, and I'll load a simulation that I've prepared for this. Nice thing about the CUDA environment is that you get to see, you can turn on visibility on the LEDs. So we've got the blue, green, and red LEDs, and they're all off right now. And let's start them up. And I've got 6 here, so I'm being a bit ambitious about whether this will actually work. So the red light comes on when it's powering on, and then the green light flashes when it's trying to connect. And then I've written a client application using the sensor client certificate that will hopefully flash the red lights. So my client application actually, let's get that over here. My client application looks like this. Yes, it's a shell script, and it calls Mosquito, talking to Oregon on the secure port and with a key pair. And it sends to the topic, publishes the topic sensor command a value of 1. And you'll never guess what, I've also got an auth application which sends the value 0. So if we're very lucky and these guys are connected, I can simply run, and certainly I will cross my fingers and hope that that message manages to actually get through to the brokers. But by the way that they're flashing their green lights rapidly, it looks like they're still connecting. So let's just see if we are receiving any data. If not, I fear I may quit while I'm ahead and move quickly on. It all appear to be pretty dead. All right, I'm going to try this one more time, and if that doesn't work, then we'll call it a day. So red light on as they power up, green light on as they connect, and I'll just keep an eye on the my subscription here to the sensor data topic. I hope to see a little activity very soon. There's certainly lots going on. This debug output are all rapidly trying to connect. And I can tell you that my laptop fan is going quite loudly. But alas, we have no data. Looks like I'll have to keep you wishing on the blinking lights. Maybe I'll throw in a screenshot when we distribute the slides. So unfortunately, no blinking lights today. Apologies. But it's about time we wrap up and get towards the Q&A. So I'll just quick recap on what we've looked at: load balancing, health checks, the session persistence, the selective TLS, if you take my word for it, and the client certificate authentication, which, although is working, isn't managing actually to distribute messages around the system. When you do see the slides, a number of resources here based on sort of previous work in this area, and of course all the individual components that I've used to put this all together. So with that, I'll thank you for your attention, and maybe I'll just leave that on the screen while we switch back to Q&A.
Benjamin, you're on mute.
Thanks for that. So I'm back. So yeah, the questions, we'll try and take them in order. There's a lot, and there's still time to send your questions. Starting maybe with the health check, and I think this is a question, a more general question. Is this something that's available in open source or only in NGINX Plus? I guess in general, maybe you can clarify like what people can do with NGINX open source and what's only maybe part of the premium version.
Yeah, so the health check that I showed you with the match block with the hex strings for the simulating the connect packet, that's an NGINX Plus feature. What NGINX open source will do by default is if it fails to connect at a network level, then it will for a while not send any more connections to the same backend, and it will try again a little while later. So we call those passive health checks because it's reacting to the net traffic as it comes in, whereas with NGINX Plus we have proactive health checks which fire in the background on an interval.
Right.
But just to clarify, that's the only of everything that I showed you. That's the only NGINX Plus feature, along with the dashboard to show the health of the system. Okay,
makes sense. I guess that brings us to Paolo's question, which maybe you already partially answered. Are there other ways or simpler ways to do health check? For example, just opening the TCP connection to the broker. And are there other ways to do health checks?
So with NGINX Plus, we also support just a simple port check. But I guess I answered the open source functionality is as I described it a moment ago.
Okay. So when setting up an MQTT cluster, can this be dynamically expanded?
So it can. I've been able to. I mean, and I guess I did that with the VernMQ containers by adding a third one to my cluster. In order for NGINX to become aware of additional brokers, if you're adding them in a truly elastic environment, then NGINX Plus has the capability that it can use service discovery with a DNS interface to automatically keep track of all of the new and the old servers as they come and go in the cluster. But you can also just add that to your NGINX configuration file and have it reload. The reloads are completely seamless. You won't lose any connections with NGINX when you reload a configuration. So it's entirely fine just to add some new scale up, add some new servers in there, and reload configuration.
Okay, sounds good. Another question around, so when doing scripting, is JavaScript the only available option, or is it possible to use Lua maybe as well?
Yeah, so NGINX in general can be scripted with Perl, with Lua, and with JavaScript. I would need to check, because I can't say for certain from memory whether Lua supports layer 4 protocol work, or whether that's only available with JavaScript. Certainly for HTTP use cases, Lua is very, very sophisticated, and you can do a lot. But I've never used it for layer 4 work like this.
Okay. A question from Ali. Is there any discount or support for students with some courses or training for things NGINX related?
Sorry, I lost the middle of that. It got a little bit choppy. Was that for what kind of activities?
Training support for students, or online courses that you would recommend for people who would like to get more familiar with NGINX.
So, the best way to get familiar, I mean, so that we do have NGINX University classes, but if you're on a student's budget, my recommendation would be twofold. Firstly, to check out lots of the good articles, the admin guide, and the blog post in particular on NGINX.com. And for advanced queries, the NGINX open source mailing list is also very active and have lots of very knowledgeable people who use the product every day. So NGINX.com is full of resources.
Good. Yeah, I'm sure that helps. That will help, Ali. I think we are probably running out of questions. I don't think I see. I see more in the pipe. If you're watching us and there's a question that we forgot to answer, we still have a couple. Yeah, a couple minutes. While maybe I do some general announcements. I will be posting a link in the chat, and we will also be making this available in the comments of in the description of the recording. Like I mentioned at the beginning, for those who were here, and Liam also actually mentioned the Eclipse IoT Developer Survey. I mean, it's more than Eclipse, actually. We run this in partnership with several organizations. If you're watching this and part of this meetup, it's very likely that we want to hear from you. What stage are you at when it comes to building IoT solutions? Are you just educating yourself? Are you actually doing this for a living? What kind of programming languages are you using? What kind of databases, servers, gateway stacks? This is something that we really want to know, and more importantly, we're looking at the trends over the years of what technologies seem to be sort of taking off in the IoT field. So yeah, please take a few minutes. And I realized that yeah, the link I couldn't post. It's considered spam, I guess, but it's in the description now of the YouTube video, and we will be sharing the results sometime in April. We'll probably do a meetup actually to chat about what our findings. So that's one announcement, and the other would be our next meetup. When, like I said earlier, that will be around digital twin with the Eclipse Ditto project. So that's on Wednesday, February the 7th. So that's exactly in 2 weeks' time at the same time. And we will be joined by Thomas from Bosch. And I think there will be cool demos as well. Not sure as cool as Liam's. Like this is actually Liam. This is the first time that I'm seeing Kuja being used for demos, and it makes me think about, like, I'm pretty sure I will try and use it myself as well. Like I really enjoyed the demonstration. I actually wondered, and that's completely random thought here. At the very end, your demo, could the problem be with the fact that you were running the simulation at more than 100%? Like it was faster than live?
Yeah, it's faster than live. Actually, I realized, and I fixed it already. So if anybody is still on and they want to see it, I can. I just tested it and it's working. But it's because I didn't switch back the change that I'd made when I did the session persistence demo. It was closing. NGINX was closing connections.
That makes sense.
So, but it's a good suggestion. So I realized that we're out of time. But let me know, Benjamin, if you want me to run the final demo. I'm happy to do that.
I think we can probably wrap up, and if you have maybe a link to a similar demo, we can certainly link to it in the YouTube in the comments. For those who are wondering why my webcam is now off, it's not Google acting up this time. It's just that I forgot to turn on the lights in my office before turning and going live, and it turns out it's pretty dark now in France. So with that, thanks. See, that's what I meant. So with that, Liam, thank you very much. So there were a few interesting links that you put in your final slide. So we'll probably copy them and include them in the description of the video for people to easily be able to access them. And if they have any questions, I think it's pretty easy to find you online. So chances are you might get some questions and some people contacting you after the webinar.
Yes,
thanks.
Please do. And I can, for developers, I can provide developer license for NGINX Plus if you want to use it for your project. So you will have my details. Just hit me and I can sort that out for you.
Yeah, I'm pretty sure. Like from feeling and the mood on the chat. I feel that many people would be interested in trying out NGINX and having access to that. So thanks again, everyone, and thanks to you especially, Liam, for joining us today. Sorry again for the YouTube issues, but we managed to do a nice session, I believe, today. Thanks, everyone. Bye bye.
My pleasure. Thanks, everyone. Bye bye.